What's up guys, Riley here, and today I'm going to be going over how to simulate sports games in Excel based off of lineup strength. So this is something different that I have not done before. Of course, I've gone over how to simulate sports games using team stats, how to simulate seasons and stuff like that. But this will be the first time that I'm actually including actual player stats into simulating games. So it should be pretty interesting, pretty excited to get into it. And there's a lot of uses for this, especially when accounting for injuries in a betting model, for example. Very, very important aspect to have is the players or the lineup strength factor as well, because you can account for when a star player is injured, which would obviously affect the team output for the game. When compared to you're just using team stats, your model is then blind to the lack of that huge player for the team that they're missing, for example. So first off, let's start with the data sets. I've pulled in two data sets from basketballreference.com, starting with the player stats for the season. Essentially, for this model, you just need player, position, team, and then minutes played and points per game. So you don't need too much, but I've just pulled in this extra data as well along with it, and you can also mess around with projecting other stats as well, like points and rebounds and assists, for example, which I'll talk about later on. So I've made a few additions to this data set as well, just out of necessity. If you guys use the same data, you'll come across this as well. So for index matches, the team ID for the player sheet is different than the team IDs for the actual team stats. So you'll need to make a team ID sheet here. Line up the simple ID with the long ID, and then you can index match the long ID in with the players here into this column. And of course, for an index match, you need to index the piece of data that you want, which in this case will be the long ID from the team ID sheet, and then you match the short ID with the corresponding short ID in this team ID sheet, and it returns a long ID, which is the one we need later on to index these players into the actual game, the model of the game itself. And then that's all I've really done for this, so not too complex, just a little sorting out to do for that. But let's move on to the actual model itself here. So here is what it looks like, and I do have a simulation, a few simulation rows above this that I'll show in a little bit, but let's focus in on here quickly the structure and the concept. So starting off, I made a list, and I'll give you an example of what a list is here, how to make that quickly too. So simply go to data validation, then you can go to list, and then you pick the source of the list. So for example, if you want to make a list of all the Suns players here, we pull that source in, and right there is a list of all the Suns players. So that's exactly how to do that. What I've done is made a list of all the NBA teams from that team stats page. And then what you can do is then you have this list of teams, so then you can select a different team. And of course, by itself, for example, if we go back to that simple players list by itself, it doesn't do anything. So selecting Kelly Oubre doesn't actually affect the model at all. And I'll remove that list quickly here. To remove a list, you go back to data validation, and then you select clear all, and that list is gone. But anyways, so itself, like I said, by itself, the list doesn't do anything. However, when it comes to making a dynamic model like this, that will change based on teams that you select. You need a list, because if you reference this list back, I'm referencing this list in a ton of different cells right now to pull in that roster for the team, which I'll show in a second. But when I change the team, it will then change the roster, and then thus the roster is being referenced by the actual lineups used in the game, so then that will change as well. So that's why it's really important to be able to make a list and use a list in these sorts of dynamic models. But let's talk about the roster here. So this is the first important part of the model, which is being able to pull in players from this player stat sheet based on their team ID. And believe it or not, this is actually a sort of tough task to accomplish in Excel, because what you'll need to do is figure out how to make an index match formula for multiple matches. Because let's say you make an index match formula and you're calling in a player, or you want to call in players that play for the Rockets, for example. If you made that, all it would return is James Harden, because he's the first player that plays for the Rockets that's listed, but it's not going to return anyone else because it's the first match. So you need to be able to compensate for that. And there is a formula out there. There is a formula that there is out there that I've used. I looked this up. For example, I didn't have this off the top of my head, but you can use an aggregate formula. I'm going to go over all the just all the pieces of this formula here, just to show you guys how to replicate it. So essentially, you're still making an index formula. So you want to index the player name from. I'll go to the first row here. You want to reference the player name from the player stats, because that's what you want to pull in essentially. And then for aggregate, you want to do 15, which is small, and you want to do 3 for the option, and that is, let me pull up the options quick. That is ignore hidden rows, error values, nested subtotal, and aggregate functions. So it's just basically setting the option for the actual formula itself about what to pull in and what not to pull in. And then here in the array sheet, you want to do players. So you want to reference the array that is filled. Here, I'll go back to player stats. So you have F2 through F515, and in player stats, the F column is the team ID. So going back to game, you want to pull in that team ID, and then you want to set it equal to B8, which is the team that is currently selected in the list. So in that little formula right there, we're essentially testing where that team is equal to the team selected, essentially. Then we want to divide that by the same formula, so then we can get either a 1. We're basically going to be getting a 1 for those that match, and an error for those that don't match. And then we multiply that by this column is calling the row from player stats, and then we're subtracting row F1 from player stats, which is the first row of the column. And then we're going to be setting rows as the, if you look here, as reference 2. So this whole thing is laid out like this, and it's kind of complicated. I don't want to go into this specifically because it will take up too much time. So what I wanted to do is just lay this formula out, what the concept of it is. You guys can see it very clearly here. So if you want to simply copy this formula to the best of your ability, you can do that. Otherwise, you can look up exactly how to do this. So if you look up how to basically how to do an index match formula in Excel with multiple matches, then it'll come up with a nice little explainer video. I think there's already a few on YouTube that I've come across that will explain exactly how to do this yourself. But this is what I've done, and the result of this is it returns, if you fill it down, it returns all the players that play for the given team, and in this sense it's the Sacramento Kings. So I have all the Kings players listed here in the roster, and I've done the first 15 based on minutes played. So anyone that has played less minutes than 6.4 for the Kings will not be listed, and that's of course on average per game. Then some other simple things to pull in here. Index match for the position. I want to pull in the position because I want to be able to use that for starting lineups. And I've also pulled in the minutes per game, which is a very important aspect of this model here. It's actually probably the most important thing, because what we need to be able to do is project the minutes played for each player, and we can't have Buddy Hield playing 12 minutes. We need to have him playing a pretty accurate amount of minutes. Otherwise, that his numbers are going to be thrown off, and this model is going to be off because it's so heavily based off of who is playing, which players are actually playing. So that's why it's so important to do that. But let's get right into the MP ratio here. So the minutes played ratio is simply going to be minutes played per game for each player divided by 48, which is the total amount of minutes in an NBA match. And then we're going to fill that all the way down. However, the next few columns here, the adjusted ratio and ratio, which is simply like the final ratio after all the adjustments have been made, are going to be more important than this first adjustment here. So what we need to do here is make sure that we need to normalize these minutes basically to the amount of minutes played total by all players on a single NBA team in a single match, which is going to be 240. And what this number here at the bottom represents is 7.1. So if we multiply that by 48, we would be well over that 240 total. And I'll show you exactly how far over as well. But we need to get this total down to 250, and of course this is the sum of all the 240 rather, and this is the sum of all the ratios, which basically represents minutes played per minute in a game, basically. So if you multiply this number by 48, and now would be the projected total of minutes played for each player. But if we were to do that, we would be projecting over 100 minutes over the actual total minutes in a game. So what we need to do is now normalize this number, and we need to get it to exactly 5.00. So that's the goal here with these formulas. So what we're going to be basically doing here is, first off, we need to make sure that only the top 13 players have minutes played. So only 13 players should have a number in this adjusted ratio column above 0. So that's what this adjustment is doing here, or at least partially. There is another adjustment being made as well. But first off, we're doing a rank EQ, so we're ranking each player's minutes played from that column of minutes played there of all players. So each player is getting ranked. And then for players who have a rank of 13 or higher, and by higher I mean 13, 12, 11, like, up to 1, those players will be counted. And the adjustment being made to those players is shown here. So we have the original ratio, which is just that minutes played divided by 48. And then we're going to be subtracting the ratio minus, so the 7.1, the sum of all the ratios, minus 5, which is that total we need to get to. So we're basically essentially subtracting the surplus divided by 13, which is the total amount of players that will play in each game for each team. Of course, that's the max. It doesn't have to be like that for every game. For example, even the Warriors were playing with like 8 players at one point per game. But in this model, all 13 players will be given a default amount of minutes based on their ratios here. Of course, there can be injuries that can be added in and all that. But anyways, so that's how that works. So we're going to be trying to adjust this 7.1 down to a 5. And once we get that, once we make this first adjustment, as you'll see here, we're going to need to make one more, and there is a specific reason for that. So, and then this if statement is basically saying, okay, so if your rank is below 13 or below, or 13 or above, sorry, technically, then you'll be given this adjustment. If it's 13 or below, or 14 or below, so if you're ranked 14 or 15, you'll just be assigned 0. And then we're also going to be adding this RAND divided by 10,000 adjustment, and this is to account for ties. So it's basically adding a minimal number, which is, of course, RAND is a randomly distributed number between 0 and 1, and then it's going to be divided by 10,000. So it's going to be a very, very small minimal number, but it's going to be added on to all players to make sure that there are no ties, because, of course, the RAND will not be the same for any of these players, meaning there'll be a difference in resulting numbers if there were to be a tie, especially between players who have started on 0. So that's what this is doing, the first adjustment. And then we go to the second ratio, and as you can see here, like I said, it's not going to quite be spot on with 5, and the reason being that we're assigning 2 players who previously had minutes to 0, because they're not going to be able to make it into the game, because only 13 players can play in each game. So any player who is playing, 14th or 15th player will not make playing time in a game, so we need to assign them 0 for their ratio, because they will be playing 0 minutes. And because of that, we have 2 players, Yogi Ferrell and Justin James, who were playing before, who are not playing, and that results in a deficiency of minutes here projected for the game. So now we need to adjust that sum upwards again to hit that total of 5. That's resulting in 240 minutes total projected to be played throughout a match. So to do that, we're basically going to be using a very, very similar formula to that first adjustment, except this time, rather than subtracting that surplus, we're going to be adding the deficiency, basically equally distributed by 13 players here. So that's exactly how we're going to be doing that. And then, so same thing here. We're saying if your rank, which is of course your rank among minutes per game, is less than 14 here, then we'll be making that adjustment. And if it's not, then we'll be assigning you the same number that you had before, which would be that 0, but also with that RAND divided by 10,000 added to the end of it to adjust for any potential ties. So now we've come to this final number, this ratio, and as you can see here, we have the 5, meaning that 240 minutes are projected to be played. And then just to prove that, I'll fill it all the way over there. So there's the 240, perfect number for this, matching, perfectly aligning with the total minutes played projected. And as we'll see, that'll line up with all these, whatever team you select here. So let's say I'll go back here. Let's say I select a Blazers team here. You can see that eventually it lines up with that 5 and then thus lines up with the 240. So that's how to do that. And like I said, the reason we need to do that is, one, to normalize the mins, to make sure that we're not over or under projecting the total mins played in a game, and then also to actually project each player's mins total based on their average mins played so far and also their position. And then, as you can see here, we have the ranks. So we're just going to be ranking that ratio, and we'll be using that later. So moving up to the starting lineups now. So how I did this is, of course, realistically, at this point in the NBA, positions don't really matter that much. So it's not like you need to have exactly one point guard, one shooting guard, one small forward, one power forward, one center. A lot of times, like the Rockets, for example, aren't playing with any centers, meaning that there aren't going to be an equally distributed number of starters per position. So we don't need a center starting in a game. But in this sense, to make it easy on myself, and like I said, this is a simple model, I've just decided to start one player per position, but that won't affect minutes played. So let's say, for example, here we have the Pacers. Doug McDermott is their 9th ranked in terms of mins ratio, but is still making the starting lineup because he's the highest power forward in their team when it comes to that ratio. So I think what happens then here is that he's still only going to be projected to play 15 mins, but he's listed in the starting lineup. So it doesn't actually matter, or doesn't actually affect those mins played very much. All right, at all. I mean, I say very much that it doesn't affect it at all. It's just showing him in the starting lineup, just to have a set starting lineup based on positions. But the actual starting lineup itself doesn't matter as long as you're projecting those mins correctly. So that's what I've done here to actually pull the players in here. I've simply done an index match, and based on the high, it's going to be returning the first instance of a point guard, shooting guard, small forward, power forward, center in the roster. And the reason why this works, so before, when you try to pull the players in the roster, of course you need there's multiple matches that you need to pull from. So this wouldn't work, because using this simple index match formula, it only return the first instance of, for example, a Portland Trailblazers player. But in this sense, we just want the first instance of the player because that's the player in that position who has the highest minutes played per game on average. So that's exactly why this is a simple index match formula where we index the player from the roster, and we match the position to the position of the player, returning the highest player in the position based on minutes per game. So we have Damian Lillard, CJ McCollum, Trevor Ariza, Carmelo Anthony, and Hassan Whiteside making the starting 5 for the Trailblazers. But the formula for the rest of the team is going to have to be a bit more complex. And the reason being, we do want to sort this by minutes played, just for the sake of keeping things orderly, I think. And so with that, you then need to make sure that you don't have any matches here, and need to go through and sort each player by that rank, and then return the highest remaining rank available out of the players that are not starting in the starting 5. So how I do this, and this would be really easy in Java, for example, because we can use loops, but in this basic Excel, we can't use loops. There is loops in VBA, but we won't be using VBA here. Just be sticking to the basic Excel formulas. And what we can do to compensate for that is basically make a makeshift loop out of nested ifs, and nested if statements are basically what a loop is, essentially. But looking at this, we're going to be using an index formula here to start. So an index match will actually be used. It will just be expanded a bit because of the nature of the formula. And of course, we'll be starting by indexing the players because we want the player name returned. Then what we need to do for match is, of course, the first argument for match is the actual lookup value. And the lookup value that we need to use here, we're going to be matching the ranks. So based on that, we're going to need to check, okay, we're going to go through each rank. So for example, here we have a countif, and what this is doing, we're saying if countif, and we're looking through E14 through E18, which is the starting 5, 1, meaning if the rank 1 appears in the starting 5, then it's going to keep searching through these ifs. But if it doesn't, which would return a 0, because a countif would return a 0 if there wasn't any instances of the 1 in this range, then it'll actually go and find that first ranked player and return it here. So that's exactly what this is doing. It's going to be going through. So next, if 1 doesn't hit, then it'll say if countif 2. So if 2 appears in the starting 5, or sorry, if 2 doesn't appear rather in the starting 5, then it will return the second ranked player. But if they do, then it goes on to 3, Same thing for 3, same thing for 4, and then it just cycles through. So it's a loop essentially, and then it goes all the way down to 15. And it'll, by doing this, if I fill it down, so for example here, we have the 6th ranked player Rodney Hood coming in at 6. Then I'll go down here. Now 6 appears, so we'll go down to 7. Now 7 appears, so it goes to 8, then 8 to 9, 9 to 10. So that's how it works. It literally is it's a loop basically in Excel. It's a makeshift loop. It's almost like a manually done loop here, and it does take a little bit of code, but at the same time, realistically, you're just copy and pasting these if countif statements and then changing the values from 3 to 4, 4 to 5, 5 to 6, and all the way up to 15 because that's the amount of players in the roster. And then all you have to do at the end here is for the lookup array, you just put in that array for rank, because of course we're searching through the ranks, and then you want to do 0 just to return exact matches only. And that's exactly how to go about putting in all the players here to the actual lineup for the game. So it does take a little bit longer for the reserves than the starters, but still nice and easy nonetheless. And it keeps everything ordered as well, which is really nice appearance-wise too. So now let's get on to expected mins played and mins played. So what we need to do for this is simply we start off by expected mins played and just multiply 48 times their ratio, which we calculated earlier, which of course ratio is simply mins played per minute, and that's the equivalent of that. Multiply that by 48, and that's the expected mins. Now mins played here is also going to be adjusting for if there is an injury or if a player maybe doesn't play their full mins count because maybe they were injured or they came off. Maybe they were injured starting off the game and they only played minimal time, or maybe they started the game and they were fine and they came off injured halfway through the game. That's so adjusting for those sort of things pre-game. I would be more likely than not, you'd be saying, okay, well, let's say we have a Duke team maybe, and this is when Zion Williamson was injured. Let's say he is coming back, but he only is going to play 10 minutes. You can put 10 minutes as his total, and then the rest of the team will be adjusted for the fact that he's only going to be playing 10 minutes, which may be, I guess in a college basketball game when you're playing 40 minutes, maybe playing 30 minutes less than he normally does, maybe playing a full game normally. So then we're going to have to adjust the rest of the minutes played for every other player based on the fact that he's going to be playing less than actually projected. And this is exactly what this formula is compensating for here. So what this is essentially saying here, we have an outer if here, then on the inside we have an index match. So the first index match we're testing is we're indexing the ratios here, so we're going to return a ratio, and then we're going to match the player to the player to return the ratio for Damian Lillard here, for example. Then we're going to multiply that ratio by 48, and we're going to test it, and we're going to say if that ratio times 48, which is calculating that expected minutes total, is not equivalent to C14. So that's in the sense that we're basically pre-calculating this expected minutes total. Then we're going to be comparing it to the actual expected minutes total, which, like I said, we could enter it manually if a player is not going to be playing at all and it's 0. Then what it'll do is it will just return C14, which is the new number that we've inputted. So that's basically what it's doing, is accounting for players that, like I've said, that we would have set for a different number rather than their normal expected minutes total. And then, so we have, if that's true, then it just returns C14. If it's not true, then we have C14, and now we need to make an adjustment for instances in which there is any players that aren't playing their normal minutes total. So what we then do is we do C14, their expected minutes total, plus 240, which is the total amount of minutes, minus the sum of the minutes there and expected minutes played. So for example, let's say Damian Lillard playing 10 minutes instead of 30, then of course we'd be missing 20 minutes here. So there would be 20 minutes left to spread out amongst the rest of the players. And that's exactly what we're doing here. So 240 would be then 220 if Lillard was playing 10. And then so we have 20 minutes left, and we divide that by 13 minus count if, which is basically count if the minutes played there. And we're basically saying count if 13 minus the amount of players that are out. So for example, if there's 2 players out, we need to spread, and let's say 2 players out and we're missing 40 minutes. Then we need to spread those 40 minutes amongst 11 players. So that's why we need to have that formula in there. It's very, very important. Probably actually this column right here, the minutes played column, the most important, because we're actually projecting the minutes played for each player, and this is what allows us to adjust for players that are injured or out, or out completely, or miss partial amounts of the game or whatnot. So That's exactly what this does. Hopefully I've explained it sufficiently enough here. But basically all this is saying is if a player is playing their expected minutes total, then we also need to make sure that we adjust for the fact that another player, there is a lack of mins elsewhere in the team. And that's what this formula, this 240 or C14 plus 240 minus sum of all the mins played divided by the amount of players that will be playing in the game from that original 13. So that's what the mins play does. And I'll show you an example of what I mean by referencing this here. Let's say, like I said, Lillard plays 10 mins, and then Anthony plays 5 mins. The rest of the mins will be spread out amongst the rest of the players so that we still hit 240, even though I actually need to fill this down. I don't think I filled this down all the way to make sure that I adjust for that. Yeah, here we go. So now it's actually making sure that Anthony's mins are 5 and not 8, because 8 would be the mins played if he hadn't been actually playing and been adjusted for that total there. So I think I need to, let's see if I filled that down for the rest. No, I didn't yet. So make sure to fill that down there. But otherwise, here it is. So this is exactly what the men's play does. Obviously, Lillard. Oh, I'll need to go back here actually quickly and do that again because I want to make sure that we have the actual formulas in there for Lillard and Anthony. But there we go. So let's say Anthony, like I said, Anthony plays 10. There's 16 missing minutes, so then spread out amongst the rest of the players. And Anthony, and it has an effect. It will have an effect on the simulation, as you'll be able to see later on. So that's exactly how to deal with this starting lineup here. We'll be moving on to the rank, which is simply pulling in that rank from the ratio from the roster table here. And then we have points. So this is how to project points based on minutes played. Very simple formula here. Like I said, it's not going to be the most predictive, but at the same time, kind of just giving you a starting spot, as this is a pretty simple model here. So what we do for this is we are going to be using one of those handy dandy index match formula combinations here. As we index, we're going to be going to player stats. We want to return points per minute played. And I mean, obviously, you can already see where this is going. We're going to be returning points per minutes played, and then we just multiply the projected minutes played, and that's your projected points total for the game for each player. So, and then we also want to we can also adjust that for opponent strength and all that, but for this, I've just left it basic there, where it's just being used, just the raw numbers basically. And I've done the same for rebounds and assists too. If you can see in the player stats here, I have rebounds per game, assists per game, and then I've also pulled them in and multiplied those by their projected minutes played. Hassan Whiteside, pretty impressive, 11.1 rebounds projected for him. He is their starting center. And then for the Pacers, for example, 10.5 projected rebounds for Domantas Sabonis. So another nice little number there for him as well. So that's how that works. Pretty simple stuff, I think, overall. I think the main thing to figure out is one, pulling in those subs, those reserves, and doing that through a loop, or a makeshift loop in this case. Then also being able to adjust those mins played, because we need to remain with 240 total mins. There can't be a game, there's never going to be a game in the NBA anyways, where you're going to have less than 5 players playing at all times, meaning there's going to be that static number of 240 minutes played at all times combined between all players. And I say in the NBA because it actually does. I mean, it has happened in college before. I've seen it where, I think it was Alabama, Minnesota. It was actually back when Colin Sexton played for Alabama. I think Alabama played with like 3 players or something like that because they got their entire bench ejected. I can't remember exactly what happened in that game. It was pretty interesting, but I don't want to get off the topic here. But basically, what I'm trying to say is, like I said, that 240 total minutes played is going to be static. So we need to make sure that we always have that number. Where if I didn't have this adjustment being made in the minutes played column, and I changed Damian Lillard's minutes from 30 to 0 because he was out for the game, then it wouldn't be distributed through the rest of the team, and there'd be less than 240 minutes played. And another thing to note too is, obviously in a real game, if Damian Lillard didn't play, it's not going to distribute all his mins evenly among the rest of the players. Most likely, that next point guard, which in this case, I don't even know if they have another point guard listed in the team, but Anthony Simons, for example, would most likely get a lot more mins because he'd be like that next guard up, basically, that would be replacing Damian Lillard. Or there could be another different lineup combination that could happen. But what I'm trying to say is, it's in real life, it wouldn't be distributed equally among the rest of the players. But once again, just another point that I want to make, that this is like I said, a very simple model. It's a base for which you can build on. So something you guys can adjust if you are really interested in making your own model like this, you can go in and adjust this and make it actually based off of their position as well, a lot more than just evenly distributing it. But in this case, I've decided just to take this the simple way, which is just evenly distributing those extra mins unplayed among the rest of the players that are still playing in the game. All right, so that's starting lineup's done. Hopefully you guys picked up on that pretty well. And I think with this sort of model, like you don't really need to have an extensive history in Excel. As long as you're familiar with those index match formulas, which are the most important thing. I think getting over that loop as well can be a little tough too. But like I said, it really is just copying and pasting those if count if statements over and over and over again until you're done with those, until you're done with all 15 players basically. It's going to be the same thing for this side. But other than that, yeah, that's all it's going to be. So we can move on to the actual simulations here, which are up here, and then we'll show you the real cool part of the model too. So and how the actual results of the model work. So here we have the results of this game, and this is if all players are playing their projected mins totals without any effect. And we're pulling in so player points here is being pulled in, and what this is the actual points projected based on players. So we're going to be summing that total points scored by players, and then we're going to be multiplying it by a little. We're going to be basically calculating how good the opposition's defense is based on how we're going to be dividing it by average, by league average. So let's say we have Pacers here, 107.4, and then we're dividing that by the league average, which is 111.4 points against per game. And we're going to be we're going to be getting a number less than 1. So that means it's going to decrease that player point sum by a little bit, and that's basically just the adjustment that we're making for your opposition, because I think it's important to make opposition adjustments definitely, even if it's you're basically if you're basing it off of player points. I think it's still going to be affected by the opposition you're playing, and that's one thing to make sure to always do as well. Always take into account the opposition. You can't just take that sum of points because you wouldn't be taking into account which team they're facing. So obviously, facing the Pacers is a lot different than facing the Kings, for example. So Pacers with a really strong defense, the Kings maybe not so much. And that's exactly why we make this adjustment. So we're pulling player points for both teams. It's the same formula, and the reason I've added the plus 1.5 is for the home advantage. So I think 3 points is generally the accepted home advantage in the NBA. I could be wrong, but that's what I found. That's what I read on when I went and did the little looking into that. I found that 3 points was generally accepted. So what I've done is I've added 1.5 points to the home team's total and taken away 1.5 points from the away team's total, and that adds up to be a total of a 3-point difference between the home and away team for home advantage. So that's player points, and we have team points, which is basically just going to be that points for an average total for the teams, and this is exactly what we used to simulate originally that first video that I made to simulate the Warriors and Rockets game done back in 2018, I believe. Based on just their points for total on average. So it's a lot more basic and does not take into account who's playing at all or anything like that. So same thing for both teams, and we're going to be, of course, making that opposition adjustment again, and also making that home advantage adjustment as well. And then we move on to projected points, which this is based on the weights now. So what we can do is we can decide to weight one rating higher than the other. So in this sense, the player rating, which is just the projected points based off of your players who are playing, that is weighted at 60% of the final rating, and then the team rating is based off 40%. But if you can look at the results here, you can see is if we adjust this to like 0.75, for example, and team to 0.25, it does affect that win percentage. Albeit marginally, but still 1%. I mean, it's a definite effect there. So it is pretty interesting. I'll leave that player's rating on 0.75 for now. So then the final thing to do is simply simulate this thing. And what we can do is I'll show you the simulations tab here in a second, but here are the results of this match between Portland and Indiana. But the simulations tab, we're going to be doing it a little bit different than normal. We're not going to be using a data table, which is what we normally do. This time we're just going to be filling the norm inverse function all the way down, and that leaves us with this interactive simulation, which then can show us, let's say we want to change a player's mins. For example, if Lillard was injured for a game, we can see exactly how that affects the simulation right away without having to wait to re-simulate something. So here we go. I'll show you the formula, which is just the norm inverse. We have RAND as the probability, which of course is that normally distributed number between 0 and 1, which then affects the cumulative probability function here. And then we have the mean, which is that projection right there, the projected points will serve as the mean, and that's the result of both the team and player projected points, which you saw before. And then also we have the standard deviation, which I've done as 10, and I think I used that before as well. It might have been 15 before, but I'm gonna be sticking with 10 this time for the standard deviation of a team totals points here. So that's what I'm gonna be doing here, and what that leaves us with is, because of that rand in there, this is a live simulation, and I've done it for both teams. And the result of this here, well, the results of all the simulations here are as shown. And what I've also done here is made a column with just home win, just to basically distinct between a Pacers win and a Trailblazers win. So a Trailblazers win, of course, being the home team, will be represented by a 1. And then all we need to do here is go back to game, and we just sum that home win column and divide it by 10,000, and that's there's your probability, there's your win percentage right there, based on the simulation. So I think it's really interesting here. And then for the other one, you just do 1 minus the home win probability there. And yeah, that's going to be the result of the simulation. It is active, so it is going to be changing a little bit. There is a little bit of variation there, as you can see with the simulations. But what we can then do, which is so cool about this model, is that if we change Lewis Mins, let's say like he was injured heading into the game and he's going to be playing limited time, we change him to 10, and look at how much that affects the win probability there. Indiana increasing from about 57% to 73% based on just 20 less minutes played by Damian Lillard. So really, really interesting stuff. And one thing I did want to take a look at too is, let's say the Lakers are at home against the Bucks, for example, and we can take a look and see, how the Lakers' win percentage will be affected by a LeBron James injury, for example. So Lakers Bucks, actually Bucks are very, very slim favorites away from home against the Lakers. So really impressive there for the Bucks. But let's say, for example, and here you can see where the positional stuff, the starting fives, can be a little bit sketchy, because the Lakers don't have a listed small forward. For some reason, LeBron James is actually positioned as a point. What I can actually do is change that quickly in here, and this is something you can do too if you really want to mess around with stuff. I mean, realistically, it doesn't matter. Oh, I actually got lucky there. So he is listed as a point guard. I'm going to change him to a small forward just so we can get an accurate starting lineup, even though it doesn't really matter that much. Because, like I said, the minutes aren't actually affected by the starting lineup. But if we get James as a small forward there, we then have Rondo, Caldwell Pope, James Davis, and Dwight Howard as your starting lineup, with Danny Green, Kuzma, Bradley coming off the bench, because realistically Jared Dudley would not be starting. And then for the Bucks, we have Bledsoe, Wesley Matthews, Chris Middleton, Giannis, and Brook Lopez. That's a pretty accurate starting lineup for the Bucks there, I think. So that's how it looks right now. But let's say James can't play in this one. His win percentage goes up to 72. So a huge increase there, and I really think it's cool to see the active simulations here, which is exactly why I just filled that norm inverse all the way down 10,000, and then of course we're using that sum of the home wins to calculate that home win percentage for the Lakers. But I think it's really, really cool, and it also shows you the difference in projected points as well. So awesome stuff. And if we change the player weight, so let's say we make it that the players don't matter as much, let's change it to 40-60, and as you can see here, the win percentage does change by about 10%. So you can change the weight however you want if you add this in here. And all you need to do that is, of course, make this formula here, which is what's taking into account the weights, and we just do the player points times the player weight, and then add that to the team points times the team weight. So all that's done there. I'll leave it at, I kind of like 60-40 for the players, so I'll leave it there for now. And there you go. So according to this player weight and according to the starting lineups, and all the players that will be playing in this one, the Bucks are 68% favorites based on the fact that LeBron James will not be playing. But if we go back here and change it, I'm actually, the one thing that does kind of suck about this is that to change the player back to their original minutes, you kind of just have to hit back. So I mean, you could make something more interactive like that too if you wanted to. Not really that hard to do, but so if I change this back to 60. and then I change LeBron James is now back to 32. Let's say Giannis can't play in this one. Then it changes to 73 percent win percentage for the Lakers there, which is really impressive. And I like how interactive this model is. I think it's something that's really easy to use, easy to digest as well when it comes to visually. And it's also really easy to work with here. Quickly change it to the Pelicans. You can change it to any team you want here throughout this list. Celtics, for example. Celtics against LeBron without LeBron, or against the Lakers without Dwight Howard. Actually change much. It actually helps the Lakers a little bit, I think. That's going to be it for the day. Hope you guys enjoyed this one. I know it's going to be a pretty lengthy one, but I think definitely a video worth tuning into for the entirety, because you will take I think there's a lot of things to take out of this, whether it be just for this model or going forward for models like this in general. But yeah, other than that, if you guys have any other ideas for videos you want to see from me, let me know in the comments, and I will definitely consider. But also, I want to mention too, hopefully you guys are all staying safe, and your families are healthy and all that with this, the crazy times going on right now. But until my next video, hopefully you guys enjoyed this one. Leave a like, drop some comments, leave some feedback, and enjoy.